Hi guys, we are Pokemon team. As mentioned before, we have 4 research questions. Let's introduce our results for these 4 questions. For the first one, whether Piggy could be predicted or not, we have 2 datasets, one for SVM neural networks and comparative analysis, and one for clustering. For the first one, based on the results from Milestone3, we removed all features and only kept the 6 variables to avoid overfitting problem. We also removed all duplicate reports. Because of the limitation of neural networks algorithm, we also use one-hot encoding to transform all our 5 categorical features. For example, rarity is a categorical feature with 5 levels, so this feature will be transformed to 4 binary features. Therefore, after encoding, the dataset has 35 variables. For the second dataset, because it's hard to calculate the distance between 2 points from the perspective of categorical features, we removed all features and only kept the 6 numerical features, including wind speed, pressure, gym distance, population density, etc. We also removed all duplicate reports. In addition, we only processed 10% of overall reports for the hierarchical clustering because of the limitation of our laptop. For SVM, we found both linear kernel and polynomial kernel get to the highest accuracy, about 88%, but a moderate precision rate, just 53%. Therefore, we conclude that SVM model cannot differentiate PD from other Pokemon that share a same appearance pattern as PD, thus making falsely label those Pokemon as PD. Since linear kernel and polynomial kernel get the same result, we think the distribution of Pidgey and other Pokemon are linearly separable, but may with some noise. For neural networks, we train 3 models, one without hidden layer, one with 3 hidden layers, and one with 2 hidden layers, but that are specified 10 nodes for the first hidden layer and 5 nodes for the second. Activation function for our neural network model are logistic because there are only 2 levels for the target feature. The correlation is nearly 100% for neural networks with 2 hidden layers. Because of one-hot encoding, the dataset has very high dimension, so that the plots of neural networks is difficult to identify. For clustering, we conduct k-means, hierarchical, and density-based clustering. As we mentioned earlier, we only include numerical features into the clustering model. The result of the clustering techniques are not very accurate compared to the supervised learning, because most numerical features are not significantly related to the target feature. For k-means, it does not well cluster our data. Although from table, nearly 94% of positive reports are clustered into one class, while the model also falsely labels about half the negative reports as positive. For hierarchical clustering from table, we can see it cannot well categorize sample data into 2 groups. No matter the positive or the negative reports, most of the reports are classified into the first group. For the density-based clustering, the result is very interesting. There are nearly 70% of positive reports are clustered into the cluster 1. The density-based model did successfully predict PD and a high recall rate, but with an extremely low precision rate. For comparative analysis, we compare the results across cross-bagging, random forest, SVM, and the neural networks, but also across different cross-validation techniques, including k-fold cross-validation, k-fold cross-validation without repeat, and leaf group out cross-validation. From table, we found SVM and random forest with leaf group out cross-validation have the highest accuracy rate.
So here is our second research question. Can we predict Pokemon rarity in America region? So before any kind of methods being applied, first we did the feature selection in order to make better models. However, it is under our expectation since none of the features is strongly related to Pokemon rarity. So we still decided to use the best model from Milestone3. And for data manipulation, we transferred the rarity column from category numbers to text, and we also split it 70% of training and 30% of testing. And here is the data oversampling before and after. So as for the SVMs, we applied the methods of linear kernel and radial basis kernel. And from the results above, we found that radial basis has the higher accuracy of 42.59%. And as for neural networks, we had 3 layers and 5 layers respectively here, and both models has the same accuracy, and we can conclude that different layers may not affect on model accuracy here. And for clustering, we did k-means and k-Medowitz and hierarchy clustering. So first is the k-means, and here's the two-way table, and within cluster sum of squares by cluster, and which 92% is the measurement of total variances that is explained by clustering. And here is the plot of k-means. And as for k-Medowitz, here is the two-way table. And here is the plot. And for hierarchical clustering, we randomly selected 30 rows in order to see the dendrogram clearly. And here is the cluster dendrogram. So in conclusion, based on all the plots and tables, we can conclude that clustering is not a good method for Pokemon rarity prediction, since there is not an obvious clustering to any of the classes. So next, moving to comparative analysis. So in here, we apply 3 kind of techniques: CV, repeated CV, and boot, and 4 kind of methods: SVM, neural networks, bagging, and random forest. And on the right bottom side, here's the conclusion table of model accuracies. So based on this, we can conclude that when applying SVM and neural networks methods with CV cross-validation technique, the model reaches the highest accuracy of 45.2%.
The third question is what type of Pokemon will show in American range? Firstly, I use the package F selector to rank all 17 independent variables because we wanted to build a more efficient model. According to results, we select the first 6 features to build the model. So right now we have latitude, longitude, sunrise minute, midnight, pressure, terrain type, and sunrise minute as features. Then we divide the datasets into 2 sub-datasets. In the p-type training dataset, the sample size of each class with type 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, and 14 was enlarged to 30 multiples. Hence, the p-type training dataset has over 23,000 rows in the end. Simple distribution saturation of each type are as follows. For the first question, SVMS, we found that the model with linear kernel performs better than the model with a radial based kernel. However, both models did not get a high value of accuracy. Although some labels with small size have expanded, SVM can hardly predict the Pokemon which with a type of 5, 8, 10, 12, 13, and 15 when using a linear kernel. What is more, when using a radial based kernel, SVM almost impossible to predict a Pokemon which with a type of 1, 6, 8, and 12. For the second question, because the Pokemon type is category with multiple labels, so for labels we have 15 classes. Before to train the model, we also normalize the value of sunrise minute, midnight, pressure, terrain type, and sunrise minute to make sure that the input variables to the nature network to make a range between 0 and 1. We created 2 models. The first model has 3 hidden layers. There are 2 neurons in the first layer, 3 neurons in the second layer, and 2 neurons in the third layer. The second model has 5 hidden layers. There are 2 neurons in the first layer, 2 neurons in the second layer, 3 neurons in the third layer, 3 neurons in the fourth layer, and 3 neurons in the fifth layer. The active functions for both models are same, logistic. However, in natural network, we found that different hidden layers did not have a scientific impact on accuracy of model. Forecasting, firstly, we use the K-means method. This is a two-way table, and we picked pressure and sunrise minutes to plot the distribution of each cluster. The second one we use is meteorites. This is a two-way table, and this is a cluster plot. The third method we use is hierarchical. In order to make sure the figure can be viewed clearly, we only picked 35 samples from dates randomly. This is the figure. And for the first question, comparative analysis. To make sure that R can run efficiently and display the results, we randomly select 5,000 rows of dates from a dataset. We use the following 3 cross-validation techniques. The first one is CV, second one is repeated CV, and the third one is both. By testing the same formula and compare results across different classifiers and cross-validation techniques, we found that the SVM model with radio-based function kernel performed the best with the highest accuracy. It's around 43%.
Hello everyone. Here's the fourth core research question that we have. We're interested to predict population density based on our Pokemon dataset and the independent variables that we have. From milestone 2, we selected 6 most correlated variables to use in this milestone. Those are urban status, terrain type, continent, weather, gym distance per kilometer, Pokestop distance kilometer. So the dataset is divided into training and testing sets randomly using an 80 to 20% ratio respectively where it is needed. It is also noteworthy to mention that in some cases the analysis took a long time to finish, like forever. So in those cases, a random sample of dataset is used to expedite the analysis. Starting with SVM technique, we use 3 different kernels, linear, radial, and polynomial. And among those 3 models, we noticed that the second model, the radial one, got the highest accuracy, about 76% of accuracy. And for this particular technique, we used 10% of our original data set, approximately 28,550 records to expedite the analysis. Now we get to neural network analysis. We used 2,855 records, approximately 1% of the original data set because of the limitation of our laptops. And here are the results for neural network analysis for 3 hidden layers. You can see the accuracy is about 72% after the analysis. Now we get to clustering methods, starting with K-means. It's noteworthy to mention that the dependent variables divided into 5 categories using minimum first quartile, median, mean, third quartile, and maximum values to perform classification analysis, since our dependent variable is a continuous one. For this method, the whole original data set is used. Ideally, so from the results on the right, you can see that K-means performs poorly in terms of clustering our data set, because ideally we're interested to see each cluster should be well separated from the other ones and not having any overlaps or the minimal overlaps. As an example, here's a graph showing the visual cluster of gym distance against urban status. The next clustering method that we use is medoids. A random sample of 10,000 records are used here. Again, you can see the medoids analysis performing poorly based on the table that we have showing that there are overlaps between the clusters. A plot of the PAM results are provided here. The next clustering method is hierarchical method, and you can see in order to have a better visual here, we use only 30 records and we use 5 clusters, and you can see from the table at the bottom that shows the accuracy of our prediction. Next, we have more records of our data set, about 10,000 records, and the dendrogram is shown here, which is not that readable, but the details of the prediction and the clustering is provided at the bottom. Again, it seems the clustering is not performing at the very best. The last clustering method that we're using is density-based method. We're using approximately 1% of the original data set, 2,855 records, and the plot shows gym distance against urban status as an example, and the table shows again clustering using density-based, and again it shows that the clustering is not performing very well. And lastly, for comparative analysis, we use different cross-validation techniques: CV, k-fold cross-validation without repeat. Second is repeated CV, k-fold cross-validation. And lastly, LGO-CV, leave group out cross-validation. From the right table, you can see that among different techniques, random forest got the best accuracy among all other types of techniques. Any questions? Thank you so much.